Alright, so in this example problem, let's talk in depth about stereographic projections. And what we'll do is that we will not just draw the standard stereographic projection, but we'll also solve several other questions. So for example, we'll begin with drawing the stereographic projection of 0, 1, 0 and having the 1, 0, 0 pole at the north point. We'll compute the angle between any two given poles, both analytically and through the Wolf net. We'll draw the trace of any given pole, and then we'll find the zone axis of two given poles. Zone axis is simply an axis that is perpendicular to both these poles. And then we'll do it analytically and then also mark it in the stereographic projection, and then we'll point out other things in the stereographic projection. So I'll split this video in smaller parts, but we'll keep the setup the same. All right, so let's begin. Now, the first thing that you will need for something like this, where you have to not just draw the stereographic projection, but also find other things, is a printout of a wolfnet. Now, you might be given transparencies and other things, but here's a very simple trick to solve such problems without any extra transparencies. All you need is a wolfnet printout, something like this. It's a normal page that you can use. And then if you have this printout, which will likely be provided to you, or you can probably just bring it with you in the exam, and then all you need is just another extra page. So here I just have a typical A4 or a letter size page from a photo printer, and or just normal printer, and then we're going to use this, on which we're going to solve our question and draw the stereographic projection followed by other things. So let's just see how we can do that. All right, so the first thing that you would want to do is sort of find a hard surface underneath, and then you could just use a book or the table itself, and you can then take something like a thumb pin and then this page. So the idea here is that we want to put this page right above the stereographic projection. Now, the good thing with even the thickness of this page, and if you see carefully, you can see some of the tracings. And then in the closer you look, you can see even the rest of the tracings of the stereographic projection. So in this, it might be a little harder to see, but when you practice it, you'll be able to check how well does your transparency look. And you can see that here, you can see it to be really transparent. Let's just hide this. All right, and then with this, you can see all the outlines here. And another simpler way even to use is tracing paper or even the baking sheet. So if you have baking paper at home, you can just use that, and that makes it even simpler to work with something like this. And you can see how you can draw anything on this tracing paper and attach that as your answer sheet. So how do we set this up? So let's figure it out. So we have these two pages, and then we have a thumb pin. So I am gonna align this in a way that my baking sheet or the tracing paper can cover this entire thing. And then I will take the center point of the wolfnet, which is at the bottom, and then place the thumb pin in there. All right. Now, one thing to keep in mind here, the only thing you will rotate throughout the entire question to solve the question is the top sheet where your answer will go. The wolfnet stays just like that. Now, the first thing you do want to do once it is stable and it is pointed down and held down really well is just trace out the boundary and the four major axes. All right. So I am just tracing out the outermost great circle, and this will help us in case the thumb tag comes out, we can easily put it back properly in place. Now keep in mind, because the thumb tag has a certain thickness, this might slightly wiggle around that center point, so it might slightly move, so just be very mindful of that. And then along with marking this outside great circle, we will also mark, all right, so then we'll also mark the two diameters, the two main diameters. So This goes here. And as you can see, I'm using a pencil, and that is something that I would recommend. So now you see how I move this slightly before even marking the other, but the good thing is that I can easily bring it back to the center point. And then same thing on this side, where we want to mark the other diameter, which is perpendicular to the first one. And you can see how easy it is to trace this all. And you don't need any the transparency, special type of transparency paper. This is just a tracing paper or a baking sheet that you might have at home. And you can just buy this in bulk and even share it with your classmates. Simple tracing paper. All right. So now once we have this, now we have the system set up to solve our question. So let's look at the question again. I'll just hold this up real quick. So we have to draw a 0, 1, 0 standard stereographic projection of a cubic crystal with a 1, 0, 0 pole on the north. All right. So since I've done this several times in the previous questions, I'm just going to quickly run through this. And I hope that you're able to recall it, and you can also practice doing it by yourself. So the 0, 1, 0 goes in so the question is 0, 1, 0 as a standard stereographic projection, and then the 1, 0, 0 is my north pole. So I'm not going to describe it in detail. I'm going to quickly fill up all the, and then you can follow my steps and see how much time should it typically take to fill something like this up. And keep in mind to keep this stable over that the diameter should be aligned with the wolf net. So this is 0, 1, 0. The north pole will have a square of 1, 0, 0. So now I'm gonna see the outermost axis. This is the y-axis. The one coming outside is the x-axis. So the z-axis should be on this side. This was 0, 1, 0. One coming out from the center. This is the 1, 0, 0. So this should be 0, 1, 0. So this should be my east. This was my center, and this was my north. So the east, this will be 0, 0, 1. This should be 0, 0, 1. And then the south on the opposite edge, this will be 0, my bad, that'll just be the opposite of the north pole. So that will be 1 bar 1, 0, 0. And then the west over here, and all these are square notations, by the way, this will be the opposite of the east, which is the 0, 0 bar 1. All right. And then 10, 20, 30, 40, 45, 10, 20, 30, 40, 45, 10, 20, 30, 40, 45, 10, 20, 30, 40, 45, 10, 20, 30, 40, 45, 10, 20, 30, 40, 45, 10, 20, 30, 40, 45, 10, 20, 30, 40, and then 45. Now let's quickly label these. I'm just going to do a quick vector sum. This will be 0, 1, 1. This will be bar 1, 1, 0. This will be 0, 1, bar 1. This will be 1, 1, 0. Filling up the outermost, bar 1, 0, 1. This will be bar 1, 0, bar 1. This will be 1, 0, bar 1. And then this guy will be 1, 0, 1. And then again, if you remember from the previous example problems, the next thing that I like to do is just join the two lines. Now, since in this, even if you don't have a ruler, I would still recommend using a ruler, but it can be difficult with the thumb pen on. I just recommend you to rotate this baking sheet or the tracing paper that you have so that these two poles come on this horizontal axis, and then just use that to draw or trace out that horizontal diameter, and that will be a very quality trace. And then same thing you can do with the other two, which is now just the vertical, and this will go to the top, and then this will go over here. All right, so we have these marked. All right, so after we have finished all the two-fold poles, now we can draw the three-fold. If you remember, The quickest way to draw that is just draw the great circle corresponding to all these internal poles or either the two, and then wherever that intersects with this axis, that is where your three poles will be. So I'm just gonna quickly draw this in this manner, both the sides, and same on the other side, where this will go something like this, and then something similar here, and then these points just simply now become the intersection, the vector sum of the center and the outside. So this will become 1, 1, 1, and then this intersection will become bar 1, 1, 1. This intersection will become bar 1, 1, bar 1. These two will, or these two will give 1, 1, bar 1. And you can also see now to calculate the angle. So let's say someone asks you to calculate the angle between 0, 1, 0 and 1, 1, 1. This might be a mistake that I made on one of my previous video where I did say that everything is on the same angle. But in reality, what happens is that to find the angle between 0, 1, 0 and 1, 1, 1, you want to get them on this great circle and then now count the angle. So you'll see here it's 10, 20, 30, 40, 50, 52, 54. So it's about 54 point a few angles. And then same on this side, same on this side, and then same on this side. So these are all about 52, 54 point a few angles. All right, so this is the part A of the question, which was the standard stereographic projection of 0, 1, 0 along with a cubic crystal with the 1, 0, 0 pole on the north point.